Here what we're going to look at is one of the key rules associated with differentiation, and that's what's called the product rule. Now the product rule applies when we can write some sort of function in the format of two or more functions multiplied together, and we have to take that function and take the derivative of it somehow, which we can use later on. They always seem to follow the same format, which is fairly straightforward. Now let's imagine we've got two functions, f of x and g of x, both of which are differentiable. If we write that in the format y of x equals f of x times g of x, what we can do is to take the derivative y dashed of x, we simply take f dashed of x g of x, so derivative of f of x times g of x, plus the original f of x times g dashed of x, the derivative of the g function. It's quite simple. We follow that through. Now proving it is also actually fairly straightforward. So let's imagine we've got y of x being this format here. What we know is that the rule for differentiation is y dashed of x is equal to the limit as h tends towards 0 of y of x plus h, take away y of x, all over h. So that's our rule for differentiation. So if we've got it written in this format where y is equal to f of x g of x, we can rewrite this as the limit as h tends towards 0 of f of x plus h times g of x plus h take away f of x g of x. Now, and then that's all over h again. Now we have to rearrange this in the format that proves what we want here. Well, here is a cheeky wee step that becomes apparent as to why we do it a little bit later on. What we're going to do is we're going to add and subtract f of x times g of x plus h. So what I'm going to do is I'm going to rewrite this top line. Let's just look at that all on its own here as f of x plus h, g of x plus h, and what I'm going to do is I'm going to take away f of x times g of x plus h. I'm then going to add it so it cancels out ultimately in my final calculation. So I'll get f of x, g of x plus h, and then I've got my final part of the function, take away f of x, g of x. So what I've done is I've rewritten that entire top line in that format here. Now the reason we've done that is what I'm going to do is I'm going to take this top line here and I'm actually going to split it in half. So I've got a half of the function here and I've got a half of the function here. Now if you look at this side of the line here, you'll notice that g of x plus h is a common factor of both of them. So what I'm going to do is I am going to take g of x plus h out as a common factor. So what that'll do is that'll leave me with f of x plus h, take away f of x, all multiplied by g of x plus h. So that'll be within a bracket because I've taken it out as a common factor. And in this side here, f of x is a common factor, so same idea. I'll end up with g of x plus h, take away g of x, all of that times f of x. So what I can do now is stick that back into here. So if I stick it back into here, what I can then say is I can rewrite y dashed of x as the limit as h tends towards 0 of, and then this would now be my numerator, f of x plus h, take away f of x, all multiplied by that common factor we took out of g of x plus h, plus the second part here. So I've got my g of x plus h, take away g of x, times that by the f of x, everything's over h. So what I can now do is, since these are added together, I'm going to split them off into their own parts. So what I'm going to do is I'm going to say that that is equal to the limit as h tends towards 0 of this first part here over h, and I've then got a second part here which will be all on its own. So what that means is I'll split it, and I'll have the limit as h tends towards 0 of f of x plus h, take away f of x, all over h, and then times by g of x plus h. Just a slightly different format. Again, it'll become apparent why in a moment. I'm then going to have plus the second part all on its own again as well. So let me cut off that first part there. Plus the limit as h tends towards 0 of that second part, g of x plus h minus g of x all over h, this time times the f of x. So I've split it off into two separate fractions, all on their own. Now if you look at each of these parts, what you'll notice is this here, the f of x plus h minus f of x over h, that there is the definition of the derivative of f dashed of x. And what I can also look at is the fact as the limit as h tends towards 0, this becomes just g of x. So that can be written as f dashed of x times g of x. And then this second part is the same logic. This here is the written definition of g dashed of x. And then I've just got f of x on its own, so I've got times f of x. And I've got my add in the middle because I've split it. So what that then means is I've shown that if my y of x equals f of x times g of x, then y dashed of x is equal to f dashed of x, g of x, plus f of x times g dashed of x. Sometimes you'll see very shorthand versions of it written as y dashed equals f dashed g plus fg dashed, or this second one may even be swapped around. So again, I've seen it written f dash g plus g dashed f. They're all the same format and they all mean the exact same thing. Make sure we follow this whenever we're working with this sort of stuff. This kind of thing here is one of the basic fundamental rules of differentiation. We have to be able to use it. We have to be able to identify the format and be able to use it. We have to allocate an f and a g, calculate derivatives of them both, plug it back in the formula, and see what we get. Now, easiest way to do this is for me to show you a couple of examples. Let's imagine I give you y equals x squared times sine x, and I want you to differentiate that. First thing I'm going to do is I'm going to assign my f of x and my g of x. So my f of x, what I'm going to do is I'm going to make that the x squared. And I'm going to make my sine x the g of x. What I'm then going to do is calculate the derivatives of them. So if my f of x is x squared, I know that f dashed of x is equal to 2x. I know that if g of x is equal to sine x, that g dashed of x equals cos x. And then it's just a case of plugging it all together. So y dashed of x, in this case, we know it's going to equal f dashed of x times g of x plus g dashed of x times f of x, and then it's just sticking the parts in together. So f dash g, what that will be is 2x sine x plus g dashed f will then be plus x squared cos x. So we can just leave it in that final format there. There are times where it may be useful to take the x out as a common factor, so to have it written as x bracket 2 sine x plus x cos x. We may need to do a further calculation where we'll ultimately be able to cancel out an x as a factor. If that's the case, write it like that. Otherwise, you'll be fine just leaving it in this format. Second example for you. Let's calculate the derivative of x plus 3 cubed times x minus 3 to the power of 5. Now, one way of doing this is multiplying out the brackets. We could very easily do that. We've done binomial expansions on 2 brackets before. But that takes a heck of a lot of steps to do. That'll take a lot more time than actually using the product rule to calculate the derivative of it. So let's just go ahead and use the product rule to calculate that derivative. All we do is we follow the same steps. So I'm going to assign my x plus 3 to the power 3 is the f of x. A key thing to remember with that is the powers going. So essentially, I'm splitting it off here. Everything on this side is one function, everything on this side is another. So my f of x is the x plus 3 cubed, and my g of x is going to be the x minus 3 to the power of 5. We then calculate two derivatives, so f dashed of x is going to equal 3 bracket x plus 3 all squared, and the g dashed of x, that's going to equal 5 bracket x minus 3 to the power of 4. Then we just plug it all together in the formula. So what I can do is, if I know that's the original function, then df by dx is going to equal my f dashed g plus my g dashed f. So again, I'm going to use the shorthand just to show you it means the same thing. Then plug in the two parts, so my f dashed is this bit here. So I get 3 bracket x plus 3 squared times my g times the x minus 3 to the power of 5. I then get plus the g dashed f, so plus 5 bracket x minus 3 to the power of 4. Then it's times the x plus 3 cubed. Now this sort of one here in this format, this time we do simplify it. And the key thing to look for here is common factors. So if I look at both of these, I've got an x plus 3. But in this case, I've got an x plus 3 squared here, and I've got an x plus 3 cubed. So what I can do is I can take out x plus 3 squared as a common factor from both. Same logic with the x minus 3. This is x minus 3 to the power 4, x minus 3 to the 5. So what I can do is I could take out an x minus 3 to the power of 4 from them both. Then what I'm left with is within the bracket, I've got my 3, my coefficient here. I'm going to be left with just an x minus 3, so 3 bracket x minus 3. I'm then going to have plus 5, the coefficient here. All I'm left with in this term is an x plus 3, so 5 bracket x plus 3. Then we simplify what's in the bracket, and we've got our final answer. So what I've got x plus 3 squared, I've got x minus 3 to the power of 4, and if we multiply bits out in this bracket, we get 3x minus 9 plus 5x plus 15, so I've got 3x plus 5x, that gives me 8x, I've then got minus 9 plus 15 plus 6. So there you go, I've got my final answer there. If you wanted to take out again 2 as a common factor from this one, you could. So I'd end up with 2 bracket x plus 3 squared bracket x minus 3 to the power of 4, and then I'd have changed that to 4x plus 3. That's fine as well. Both mean the exact same thing. Just be very careful of that bit. When you've got one like this and you end up at this point here, always look for a way to simplify it. Quite frequently, it will give you an answer where it's looking for 3 brackets in a set format, and it might ask you to tell them what the power is. So you have to be able to factorize it and simplify it at that point in order to be able to do it. But those are the steps for a product rule. They're actually fairly straightforward. You just need to be able to identify your f and your g, or you can add in more functions if you want. For example, if I had x plus 3 cubed, x minus 3 to the power of 5, and let's say an x plus 6 to the power of 7, so a third bracket, I could assign that a third function's name, and then extend my product rule by doing yet another term where I multiply the first two terms, so the f and the g, by the derivative of the third term. So we can expand the product rule to more and more terms and use it as needed and as hoc for answering questions of this format. Bear that in mind when you're working it through.